Hi! In this video we'll introduce some key set operations including union, intersection, set difference, and complement. So in all these examples, A and B are sets and U is a universal set that contains all the elements that we could possibly care about. So A is a subset of U and B is also a subset of U, the universal set. Okay, so the union of A and B is denoted by this U symbol. So it contains elements in A or B or both without duplicates. So X is an element of A union B if and only if X is an element of A or X is an element of B. Or it could be both. So here, A union B includes all elements that are in A or B, or they could be in both. Okay, then the intersection of A and B is denoted like this cap symbol, and it contains elements that are in A and B. So X is in A intersect B if and only if X is an element of A and X is an element of B. So you can see that the intersection only includes elements that are in both sets. Okay, and then the set difference of A with B is denoted like A minus B, or with the backslash, and it contains elements of A which are not in B. So X is an element of A minus B if and only if X is an element of A and X is not an element of B. Interesting. Okay, so the complement with respect to the universal set U of A is denoted like A complement, and it's just the universal set minus A. So it contains all the elements in the universal set which are not in A. So basically everything that's not inside A, like this. Okay, so let's do some examples. So if A is the set of 1 and 3, B is the set 2, 3, 4, and U is the set 1, 2, 3, 4, 5, what are the following set operations? So A intersect B. So this is the set of elements that are in both A and B. So that's only 3 is present in both. What about A union B? So that's all numbers that are in A or in B or in both. So if you combine them and just take the unique numbers, you get 1, 2, 3, 4. What about B minus A? Well, this is just all the elements in B that are not in A. So we just start with B, but then just remove all the elements that are also found in A. So we remove 3 because that's in A, and we're left with only 2 and 4. Similarly, A minus B is just all the elements in A that are not also in B. So we started with 1 and 3, but since 3 is also in B, so that's removed, so we're left with just 1. What about A union B complement? Well, A union B is the set 1, 2, 3, 4, and the complement is everything in the universal set right here that is not in A union B. So the only thing in the universal set that's not in A union B is the number 5. So that's going to be the set containing 5. What about A complement? Again, it's all the elements in the universal set that are not in A. So we have not 1 and 3, but then we have 2, 4, and 5. Similarly, for B complement, that's everything in the universal set that is not also in B. So we were left with just 1 and 5. What about A complement intersect B complement? Well, we already computed A complement and B complement, so we just take the intersection of these two, which is all the elements that are in both. Only 5 is present in both sets, so the intersection only has 5. Great, thank you.